My name is Alicia. I am going to be doing project 6 for OPP Generics. I'm going to start off with my character class. All right, so it represents a character from SpongeBob SquarePants. We got the attributes that include their name, species, and number of jellyfish, and they have caught. So here we have the character's name, character's species, and the number of jellyfish caught by the character. And we represented that with private string name, private string species, and private int jellyfish caught count. For my constructor, we have public character in the argument, the name, species, and jellyfish count. I'm going to have my get and my set methods for those as well. So, let me go ahead and say it. Get name, get species, set species, get jellyfish, caught count, and set jellyfish caught count. I kind of named that a little tongue twister. Alright, so my custom method, we're going to have the amount to increase the count. So, public int, caught jellyfish, this dot jellyfish count, and then we're going to add the count to increase the count, and then we're going to return the new total count for the jellyfish caught by return this dot jellyfish caught. And then we're going to go to our toString here, and it's going to print out those characters' details. All right, we're going to move on to my next class, which is the episode class. It's going to represent an episode of SpongeBob SquarePants. So my attributes, there are going to be private string title, the title of the episode, private string air date, the air date of the episode, and we're going to set a boolean for features Krabby Patty. So it's true if it's a Krabby Patty, it's featured, otherwise it's false. For the constructor, we're going to set, have the this dot title, this dot air date, and this dot features Krabby Patties. And we're going to also have the title, air date, and features Krabby Patty within those arguments. We have our getters and set methods here. So we have the get title, set title, get air date, set air date, is features Krabby Patty, the boolean, and then we're going to also set features Krabby Patty, the boolean. My custom method is a watch method. It's going to simulate watching an episode, so it's going to have the printout statement, now watching, and then the title of the episode. Alright, so we have our toStrings here, and this is also going to print the details of the episode. And within this toStrings, we're going to have that boolean. It determines the output based on the boolean attribute right here. And then we're also going to print out the title, air date, features Krabby Patty. I'm not sure if I set that in here when I set the details for the characters, but for the details for the character, we're going to print out the name of the character, the species of the character, and how many jellyfish did that character catch. And that's just in case I did not mention it before. We're going to move on to our location class. So with this, it represents a location in the world of the SpongeBob SquarePants. We're going to go with our attributes. So with our attributes, we got the location, private string name, that's the name of the location. Private double, depth in meters, the depth of the location in meters. And private long location, the unique location identifier. I did the depth in meters because we are dealing with SpongeBob. If you ever watch SpongeBob, you know they are deep down under the sea. Alright, so for our constructors, we're going to put in our arguments the name, depth in meters, and location. All right, so we have the this dot name, this dot meters, and this dot location. For our getters and our setters, we have get name, set name, get depth meters, set depth meters, get location ID, set location. Okay. So the custom method I have for this one is it's going to calculate the depth of the location in feet. So we have public double calculation depth in feet, and it's going to have a conversion from meters to feet. So return the depth meters, and you see it right here of that conversion of 1 meter basically equals 3.2808 feet. All right, so we have our two strings down here. And it's going to print out those details for us. It's going to print out for the location, the name of the location, the depth in meters, and then also the ID location. Now we're going to go ahead and go to our Bikini Bottom container class. And this is just a generic data container inspired by the SpongeBob SquarePants setting, Bikini Bottom, and it can store and manage a collection of any type of data. We had to import some things here, so we have to import array lists. We have the collections comparator, which will come in later, and then our list, and that will help us to initiate those within these containers and then our generic app. All right. It's going to have the T in the angle brackets, the type of elements to hold in the container. So we start with the public class, our Bikini Bottom container, and we have that T in the angle bracket. As I said, it helps the type of elements held in the container. And we're going to have private lists and data lists. For the constructor, we're going to have our array list, and it's going to initialize that array list. We're going to have add. It's going to add an element of the constructor and the element of type T to be added. So we have it here, add data, T element, add data list, dot add element. We're also going to have a way to remove. So it's going to remove an element from the constructor, the element of type T to be removed. And then we also have the Boolean there, true if the element was successfully removed. If not, otherwise, false. So we have it right here, that Boolean remove data, T element within those arguments, return data dot remove, so that way we can remove, and it's the element. We also going to index. So it's going to retrieve an element from the container by its index. We have it right here, retrieve data. It's going to check if the index is within the valid range of the list. The element of the type T at the specified index or null if the index is out of bounds. And then we have the return null, and that returns the null for the invalid index. So you have that if statement of the index is less than 0, that data list dot size, our return data list dot in get, so we can get the index, all within our retrieve. And you see the T as well because we're talking about our elements to retrieve. Right, we got public int determine size. The size of the container are the number of elements. We're going to return the number of elements in the container. So you have it here, public int determine size, return data list dot size. All right, we're going to sort the elements of the container based on a provided comparator, and this is why we have to initialize that, import that java.until comparator. The comparator that defines the sorting logic. All right, it uses the collections.sort to sort the initialized list using the provided comparator. So it's going to compare. Right. So in order to do that, we have the public void sort data comparator. We're going to have that initialize that super T in comparator. So once we do all of that, we're going to print all the elements of the container in the console. Right? So we have the print data, system.print, container contains, the size, and I'm going to iterate through all elements and print size. So here's that for loop for you. T item, data list, system.outPrint. We're going to have the item here. And we just got another little print statement that comes to the end of that. All right, so we're going to move on to our generics demo app. And we have imported that Java into comparator here so that I can compare it in the console later. Initialize that. Right? So the program objective, this program demonstrates the functionality of a custom generic data container. We got the bikini bottom container using the custom data types, character, episode, and location. It's inspired by SpongeBob SquarePants, and it showcased the container's ability to add, remove, retrieve, determine size, sort, print various types of data. So the input, we have no inputs as these are all initiated within the application and manipulated by the container's methods. But the outputs, we're hoping for various messages and printouts displaying the state of the generic container, including their contents before and after the operations, the size of the container, and results of retrieval or removal operations. Right. So we have the public class demo app. It's our main. And we're going to start off with a printout statement, SpongeBob SquarePants Genetic Data System Demo. All right. So we got, we're going to create our character object here. So the character, we're going to have SpongeBob equals new character. SpongeBob SquarePants, he's a sea sponge. And we know that SpongeBob is an avid jellyfish hunter, or should I say catcher, because he releases them. So 42, we're going to have his best friend, character Patrick, new character. So we're going to name Patrick Star. He is a starfish. And we know Patrick is not that bright. If you haven't seen SpongeBob, he's we won't say dumb, but he's not the sharpest tool in the shed. So we'll say he caught 5 jellyfish. We're going to have Squidward. We're going to initialize that new character. His name is Squidward Tentacles. He's an octopus. And he catches 0 jellyfish because we know Squidward is very pessimistic. He wouldn't be caught jellyfishing. He hates jellyfishing. We have the character Sandy. And we're going to initialize that one as well. New character. Her name is Sandy Cheeks. She's a squirrel. I know that's an odd thing to say because we're talking about sea creatures under the sea. But it would make sense if you watched the show. And she catches 35 because she's very bright. And so this is just a demonstration of an extra method. So we got the SpongeBob.catch jellyfish. We'll put 58 here. All right, we're going to create our episode objects. So with the episode, we're going to initialize the new episode, the Krusty Krab training video. We're going to initialize that. So the Krusty Krab training video is the name of the title. It aired on the 10th of 2002. And does it feature Krabby Patty? True. It features nothing but Krabby Patties because it's literally the training video for the Krusty Krab. Right? We're going to have episode Band Geeks. We're going to call it Band Geeks. So equal new episode. The title, Band Geeks. The date that it aired, 9/7/2001. Does it have Krabby Patties? False. Right? Our last object for our episode, we're going to call it Idiot Box. equals new episode. Title, Idiot Box. The date of air is 3/1/2002. Does it feature Krabby Patties? True. Right? Same thing for we're going to do our location objects. So we're going to start location. One of the locations is the Krusty Krab. We're going to equal new location. Name Krusty Krab. The decimeters, we're going to say 10.5. Location 101L. Location ID. Alright. Another location in SpongeBob we're going to make is boating school. We're going to equal new location. We're going to name it Mrs. Puff's Boating School. It's probably 5.2 meters in depth under the sea. And we're just going to say the location ID is 102L. Alright. Last location is Goo Lagoon, which is like the beach for SpongeBob. We'll equal new location. Name, Goo Lagoon. Decimeter 0.5, which would be kind of impossible because it's still under the sea. But we're going to say it's a little bit more shallow because it's the beach. And location ID 103L. Alright. So demonstration of character objects. I'm going to have a printout statement, character container demonstration. So you're going to have the bikini bikini bottom container. We're going to call it the characters. Character container equals new bikini bottom container. And we're going to add those characters. So system.outprint add. So we added SpongeBob. We added Patrick. We added Squidward. We added Sandy. And then we're just going to have one that doesn't have any right here because we're printing. So print data. Right? We're going to determine the size. So it's going to print out determine size so we know. It's going to print the current size of the container. So system.outprint current number of characters. Character container determine size. We're going to remove data. So it's going to print out remove data. It's going to print out attempted to remove Squidward. And then we have it right here, remove data Squidward. So we put his name so we can remove. It's going to print out attempted to remove a non-existent object. So we're going to have that character container remove data, new character, plankton, a copula plot, 10. Now, in the characters, we never put in, plankton, nor did we ever add him. So it's going to print out that attempting to remove a non-existent object. And it's going to print out the details. And then it's going to print out new size, character container. Right? We're going to retrieve data. So it's going to print out retrieve data. We're going to retrieve the element at the index of 1, which is Patrick. The character retrieve char equals character container retrieve data. And we're going to put in the index of 1, which is 1, which we said is Patrick. Conditional check, we're going to ensure that the retrieved object is not null. So basically it's not nothing. So if we retrieve null, it's going to print out retrieve character at index 1. So retrieve char.get name. We're going to sort data, and we're going to sort by jellyfish caught, count, descending. So it's going to print out a statement, sort data by jellyfish count, descending. It's going to define a custom comparator to sort characters by jellyfish count in descending order. So we're going to see that our comparator character, because we want to compare the characters. Jellyfish comparator, character C1, character C2. It's going to subtract C1 from C2 for descending order. We're going to return the integer dot comparator. So we're going to have that C2 dot get jellyfish caught count and C1 get jellyfish count. The character container dot sort data, jellyfish comparator, which we have right here, and then character container, and we're going to print out those details. Also, demonstration with our episode objects. It's going to say the same thing wherever you print out there. All right, we're going to put in here in our angle brackets episodes. And then we have episode container equals new bikini bottom container. So we're going to add the episodes, the Krusty Krab training video, Band Geeks, Idiot Box, and it's going to print out the initial episodes. And then the episode dot container, we're going to print those details. We're going to sort the data by title in alphabetical order. So, system out print, it's going to say the same thing that I put in my comments. Sort data by title, alphabetical. We're going to define a custom comparator to sort episodes alphabetically by title. So here we have the comparator. I'm going to put in this time episodes. Title comparator equals comparator dot comparing. And go to episodes, and we're going to get the titles. We're going to episode container dot sort data, title comparator, episode container dot print data. All right, we're going to demonstrate this little extra method of episode container dot retrieve data. So we have the index to retrieve, and then there's our dot watch, the method that we had in our episode of our watching custom method. All right, demonstration with location objects. System.outPrint is going to say the same thing, location container. We're going to have, when we have the bikini bottom container, the angle bracket is going to have location instead. Location container equals new bikini bottom container. We're going to add the Krusty Krab. We're going to add the boating school at Blue Lagoon. We're going to print out the statement initialize locations, and then we're going to print details. We're going to sort data by ascending this time. It's going to print the same thing, sorting data by ascending. We're going to define a custom comparator to sort locations by depth meters in ascending order. So in the comparator location, depth comparator equals comparator dot comparing double locations, get depth meters. Okay. Location container dot sort data, depth comparator, and location container, I'm going to print those details. Depth. I'm trying to say depth. Depth. We're going to retrieve the data. We're going to check depth in feet. So I'm going to print out location depth in feet. It's going to retrieve Blue Lagoon, now at index 0 after sort. And the location deepest lock equals location container dot retrieve data. Location container dot determine size. I have here 1. Conditional check. Ensure the retrieve object is not null. I am getting a little tongue-tied. So, if deepest location equals null, system.print the deepest location, deepest lock dot get name is string.format %.2f deepest lock calculation depth. We're going to calculate those depth. It's into feet. So it's going to go ahead and change over to feet. And then we're going to demonstrate with mixed data types. We're going to print out our generic string and our integer container demonstration. So we're going to have the mixed container dot add bikini bottom, add 1999, add true, and then we're going to add jellyfish fields. All right, so let's go ahead and run this. I'm actually going to pull this up because screen is not the biggest. So we can do it. So you see I ran it already, the test code. We're going to run it again. Building. Alright, so let's go ahead and move up to the top. So our SpongeBob generic data demo, character container demonstration. So we have character name, we have SpongeBob, the species is in jellyfish he caught. Same thing for Patrick, Squidward, and Sandy Cheeks. Where to determine size, the current number of characters is 4. Because remember, we added those SpongeBob, Patrick, Squidward, and Sandy. So it's telling us that we have 4 characters. We're going to remove data. It's going to attempt to remove Squidward. It's true. Attempting to remove a non-existent object. False. Container size is now 3 because we removed Squidward because he's there. And false for that non-existent because remember we tried to put in plankton, which we had never added in or made an object for. So now we have 3 characters, which is SpongeBob, Patrick Star, and Sandy Cheeks in the new size 3. We're going to retrieve some data. We're going to retrieve the character at index 1, which is Patrick Star. We're going to sort data by jellyfish count descending. Container content size 3 because we had removed Squidward earlier. And it's comparing right here. So you see the jellyfish that it compared. Here. We have our episodes, the title of our episodes, when the air dates, and if they feature Krabby Patties. Right, we're going to have the sort data, and it's showing that alphabetical order. So this is how the episodes look in alphabetical order. Band Geeks are first, Idiot Box is second, Krusty Krab is last. When initially it was Krusty Krab, Band Geeks, and Idiot Box. Now watching Band Geeks to simulate as if we were watching an episode. Right? We have the location container demonstration, and our locations that we had was the Krusty Krab, Mrs. Puff's Boating School, and Goo Lagoon, and the depth in meters that they were, and our little location IDs that we made up. And we're going to sort it by ascending order. So when they're sorted by ascending order, have Goo Lagoon first, Mrs. Puff's Boating School second, and Krusty Krab third. So remember ascending. So there we go. And as they compared, it letting us know that the deepest location was the Krusty Krab with 34.45 feet. Right? So it says the generic string internal container demonstration. Bikini Bottom container contains 4 sides. Bikini Bottom, 1990 True, and Jellyfish. That was like the end when we added those generic little things at the end. Right? So I hope this was a good demonstration of the generic types in Java through OPP. Bye.